Today, we're diving into the fascinating topic of terraforming Mars and the potential role of desert moss in this ambitious endeavor. Yes, you heard that right. We'll explore whether we can make Mars habitable using a unique method. But the big question remains: should we even attempt to terraform Mars? Let's dig into the details together. First off, let's briefly touch on what terraforming means. Terraforming is the process of deliberately modifying a planet's ecosystem to make it more Earth-like. This idea has long been a staple of science fiction, but can it leap from the pages of sci-fi novels into the realm of reality? This is where recent research by Chinese scientists comes into play. The concept of terraforming was first introduced by science fiction writers. Especially from the mid-20th century onwards, many novels and movies explored this idea. These writers suggested that to live on other planets, we need to make those planets more like Earth. Over time, this concept caught the interest of scientists, who began to investigate it as a realistic goal. Chinese researchers have proposed that a desert moss, known as Syntrichia caninervis, S. caninervis, could be the key to terraforming Mars. Found in extreme desert environments from Tibet to Antarctica, this moss is incredibly resilient and has been dubbed a pioneer plant. Scientists believe that this plant could enrich Mars' rocky surface, paving the way for other plants to grow. Let's take a closer look at Syntrichia caninervis. This plant is known for its ability to withstand extreme stress conditions. It thrives in the harsh climates of Tibet and Antarctica. But can it survive the tough conditions on Mars? Scientists are working hard to answer this question. The resilience of S. caninervis is truly remarkable. Scientists have subjected this moss to Mars-like conditions: high doses of gamma radiation, low oxygen, extreme cold, and drought. The moss survived these harsh conditions and even bounced back after losing over 98% of its water content. They call this ability drying without dying. Additionally, the moss could regrow new branches after being stored at 80 degrees Celsius, 112 degrees Fahrenheit, for 5 years, or in liquid nitrogen, 195.8 degrees C, 320.44 degrees F, for 1 month. The resilience of Syntrichia caninervis is not just physical, but also biochemical. This plant has developed special defense mechanisms to survive under stress. For instance, it has a cell structure resistant to water loss and produces high levels of sugars and other protective substances to preserve its cellular architecture and enable rapid recovery. At this point, let's take a look at the views of the famous astrophysicist Carl Sagan. Sagan was optimistic about spreading life and establishing colonies on other planets. However, we must also consider the ethical dimensions of terraforming Mars. NASA researcher Erika Nesvold addresses this issue in her essay, The Thorny Ethics of Planetary Engineering. Nesvold writes, "The goal of terraforming is to intentionally create an entire ecosystem on a global scale, which would more than likely destroy any existing ecosystem." Carl Sagan believed that life should not be confined to Earth alone. According to him, the spread of life across the universe is a natural evolutionary process for humanity. However, transforming Mars involves significant ethical considerations. This process could potentially destroy any existing microbial life on Mars and irrevocably alter the planet's natural state. We need to think deeply about the ethical implications of life on Mars. If we find traces of microbial life on Mars, should this prevent us from terraforming the planet? Perhaps we should avoid settling on Mars altogether. The answers to these questions will shape how future generations approach Mars. Erika Nesvold highlights the social and ecological responsibilities that come with terraforming Mars. She argues that making Mars habitable could be one of the most significant engineering projects in human history, but it also brings substantial ethical challenges. If we discover signs of life on Mars, we must respect and protect its natural ecosystem. Mars has always been a source of fascination and inspiration for humanity. From ancient times, Mars has been observed as a bright star in the sky and has featured in many myths and legends. With modern astronomy, we have learned more about Mars's surface and atmosphere, suggesting that it may have once had water and even signs of microbial life. In the future, manned missions to Mars will provide more detailed exploration of the planet and possibly pave the way for human colonies. However, we must approach this process carefully and responsibly, ensuring that we preserve Mars' natural state. Mars could be a new starting point for humanity, not just a scientific curiosity. The potential use of Syntrichia caninervis in terraforming Mars could revolutionize the field of planetary engineering. This plant's unique properties might initiate the biological and chemical processes needed to create a habitable environment on Mars. However, more research and experimentation are necessary to achieve this goal. Scientists are conducting various simulations and experiments to understand how Syntrichia caninervis could establish an ecosystem on Mars. Questions about how this plant can grow on the Martian surface, which other plants it can coexist with, and how it can alter Mars' atmosphere will be the focus of future research. The terraforming process involves not just biological, but also significant technological challenges. Factors like Mars' atmosphere, surface temperature, and magnetic field pose considerable obstacles to making the planet habitable. Therefore, scientists and engineers must develop new technologies and methods to overcome these challenges. For example, various methods have been proposed to thicken Mars' atmosphere and increase its temperature. These include placing giant mirrors on the Martian surface to reflect sunlight, releasing greenhouse gases to warm the atmosphere, and triggering volcanic activities to increase atmospheric pressure. However, each of these methods presents significant technical and financial challenges. Establishing colonies on Mars could be a monumental step for humanity. However, achieving this goal requires overcoming many obstacles. Manned missions to Mars will need to develop technologies and life support systems capable of withstanding the planet's harsh conditions. At this point, it's important to consider the views of the renowned scientist Stephen Hawking. Hawking argued that for humanity to survive in the long term, we must spread to other planets. According to him, the depletion of natural resources and environmental issues on Earth will drive humanity to seek life on other planets. Mars is one of the closest and most suitable candidates in this context. In conclusion, we need to think about whether terraforming Mars is possible and consider the ethical dimensions of this process. It's clear that desert moss S. caninervis could play a crucial role in this endeavor. However, answering scientific and ethical questions is vital for the future establishment of human colonies on Mars. The future of life on Mars could push the boundaries of science and technology. However, we must not forget our ethical and environmental responsibilities in this process. Mars could be a new starting point for humanity, not just a scientific exploration. Therefore, we must proceed cautiously and thoughtfully with every step we take towards Mars. Don't forget to subscribe to our channel and turn on notifications. See you in the next video. Goodbye.